Obviously, when we talk about Shiny, you always have to have the obligatory. Let me see. Like, what is Shiny? Right? And so our studio defines it as a web application framework for R. Turn your analyses into interactive web applications. I mean, these are really nice buzzwords to like tell people what you can do. And it says like you need to know no HTML, CSS, or JavaScript. None of it's required. And that's kind of like a small caveat. That's not 100% true, or at least for the stuff that we do, right? So for example, let's say you're going to make a plot in R, right? And you had X's and Y's. You're going to do a scatter plot. So to make a plot to actually give someone, and you told them, you don't need to know how to do R at all. You just need to give me an X and Y, and I'll give you a plot. Like, that to me is what that's saying. And that's true. I can give you a plot. But is it going to be a plot I want to give somebody? Probably not. Right? So there is still a decent amount of customization that you might want to do for certain things, but a lot of people have built a lot of things in a Shiny. So I first off want to go to the gallery to show you like some of the stuff that you can do. And this stuff is actually nowadays, in some respects, kind of mundane with respect to Shiny. And I say that because this is a gallery kind of like showing you how to do things that you'll eventually want to do. Not like this is the craziest thing somebody's done with Shiny. Because some of the things are like rather intense and they're borderline on the point of like, yeah, it's Shiny, but this person wrote a whole lot of JavaScript as well. So just my recommendation, if you were to like think about, you know, what should I learn maybe to be a data scientist or whatever, right? So there's a lot of options out there. Like, do you learn C++ to try to make code really fast or some sort of machine level language? Do you learn Python because like that's cool now or something and it's a big piping language? So Python is really big. So I would say on top of R, Python would be really good to learn, but it's very similar to R in a lot of respects for what it can do. It has some extensions in some areas, but it has some pitfalls. Like it doesn't necessarily have some of the state-of-the-art stats yet. There is a big effort to do that, but it does have some more extensions to piping and that kind of stuff. And it is a different kind of language, different object-oriented language that might be better. Or you can learn kind of JavaScript, right? I think in terms of data science, I think some of these are important. So what's the big drawback or allure of doing JavaScript over like Python or MATLAB or like any of the other analysis languages out there? In that JavaScript has really become a high-powered interactive graphics language, right? So there's D3, JS, there's a whole bunch of other things out there that pretty much, if you can code it up in JavaScript, you can get it on a web page, and anybody can see it from anywhere. No installation required, and pretty much, I don't know if you've gotten collaborators who are very not tech savvy, everyone can open a web page, okay? Like, from people born in the 20s to, like, people born, like, 3 years ago. Like, pretty much, like, my niece and nephew are, like, 3, and they can, like, open web pages and stuff like that and see visualizations. So I'm saying web-based visualizations are a big thing that can not necessarily set you apart, but can make some really nice things for, like, a resume or if you guys read the New York Times and look at like their kind of infographic section, they can do some very powerful stuff. So, I mean, let's look at one of these guys. Let's look at a movie explorer. And so this is one of the things I'm getting to, is that Shiny is great. It's great if you know R. But if you want some seamless, kind of quick graphics, quick kind of web-based thing, Shiny might not be the end game that you need to go for. So this is a plot where it says, this is the number of reviews in the tomato meter, right? So it's saying, like, let's look at some of these. This one has a whole bunch of reviews, like over 300 reviews, and this is tomato meter, which means like it's a good movie or a bad movie. So something out here, for example, which has a tomato meter of like 35, but a bunch of reviews, which cost $125 million, right? Terminator Salvation, that would be considered, in my opinion, a flop, right? That like, by flops in terms of like audience satisfaction, not necessarily in terms of money, right? I don't know how much the budget was, but it's like you put $125 million into it, and about 30% of the people like it. So 2 out of 3 are like that movie is not good. Okay, but you see here we have data over here. Some of it has attributes to it. You can subset the data and it'll replot, right? So we can actually look at the top tomato meters, or sorry, top number of reviews. We can look back to like the 1940s. We can look at the Oscar number categories. So really, this is just different facets or different variables in your data that you can start subsetting the data to interactively explore. Okay? And then usually you have some sort of description of what's going on. Like something relatively simple as this with sliders and stuff that is pretty clear, right? They label these things very well to say what they are. It's not like rot underscore score, right? You don't put like variable names and stuff like that in there. So general stuff that you would do for normal figures apply to kind of shiny graphics or shiny apps. But and a lot of these kind of show you plots, right, on the right-hand side. But that's not to say that you don't want to do something with data. So this is what's called a data table object. So people, right, we have like 10 words mix over and over again with respect to stats, data, table, figure, plot. This is not, so there is a data.table package in R. That is not what I'm talking about here, right? That is a object in R that kind of replaces data frames. We're not talking about that. Data table, capital D, capital T, is a JavaScript type table that is interactive. So if you want to like explore your data or look at like maybe a table of results where you can sort on things, you can subset things, right? You can filter. It's just like a generic, like it's kind of like maybe not a database is the best way to say it, but like kind of like a souped up Excel spreadsheet, right? Except I don't think I've ever gotten it to the point where I don't know if like you keep sorting it. Like I think it'll keep additionally sorting. Do you know what I mean? It's not like it's going to just start randomly sorting the other things. It'll keep the ordering if it can. No, that might not be true. Right? I'm not. Oh, I only took 6 cylinders. But like, for example, if I sort this and then this. Yeah, it tries to keep the ordering that it was previously. So, and what I'm saying is, if you have years being the same, but I ordered by the displacement or whatever this was, it'll sort by year and then this. Okay, so that's like viewing data. So all these have like different demos, right? And some of them can get like really, I wouldn't say complicated, but complex in a good way or bad way, depending on what you're trying to convey. But check out the gallery. Check out some of these things because all of them have code, right? Code, and it's there. Right? So don't start shiny apps from scratch. Use somebody else's code. Start building on that. That said, some of it is complex and somewhat customized. So it's not always 100% easy to like kind of take their code and ram it into whatever you're trying to do. All right. This is, let me see if I can make this smaller. It makes that smaller. Let me open it in the browser. So, I believe this is the basic, shiny, like 101 app. Everybody kind of does this. It's on their website. And mostly everybody presents this because I believe most people are lazy, like me, and I didn't want to do anything else. So I just took their basic one and started with it. So if you start, and I'll show you how to set up everything that we're going on, but let's look at the kind of basics of a Shiny app, and this is very, very simple. We have a plot. We have some inputs or some type of things we can manipulate, and it manipulates the plot live, right? So I'm going to change the bandwidth. Let's make it real wiggly. Right, so we're trying to estimate a kernel density with different bandwidths. We're trying to make a different histogram, right? By the way, who's made a Shiny app before? One. Steven, you ever made one? Really? I'm surprised. You've done a lot of interactive stuff. So you can do some interactive like toggling and that kind of stuff. And so I think the big question is like, why do I even care? I know how to do plots and all that. I can do, 3 plots and look at the differences, right? Let's say I want to do a histogram and I want to see if the bins, like if I want to make it a little bit more like, I can do that. I can plot 3 plots and just look at the differences, right? Let's say I want to do that for 100 times. I'll open up a PDF device and dump 100 histograms in there, and I can toggle through with PDFs, right? When I started, that's something I would have done, right? And that, when I started, Shiny didn't exist, so that was like what you did, right? You open up a PDF device and you plot histogram with bin equals this, bin equals that, bin equals that, and you kind of flip through them and pick one, right? The interesting thing is, for all the good things base R is, it's not very interactive in the sense that you can't manipulate plots post-make, right? You make them, you look at them, you change them, you have to make them again and render them again, right? And it's interactive in that, but a lot of people necessarily aren't coders, and a lot of times you don't want people to have to do that. You want easy stuff, intuitive things that you use all the time. So now, like, why should you care, right? Who's got collaborators here, right? In the School of Medicine, right? Have you ever asked them to code anything or run a bit of your R code? No, right? Because you ask a doctor to do that, they'll be like, no, or like, why are you on this project if I have to do this? In some respects, and so you want to show results, or you want to show something compelling, and again, everybody can open up a web page. And that's not to say doctors can't run code. It's just usually easier for collaborators if you're trying to display results and you want to get them to interact with the data. A Shiny app can be really helpful for that. All right. So the user can interact with the data and R. So, right, R is usually a one-way system. Right? Type in R gives you stuff back. But that figure that you rendered can't talk back to R. Right? Does that make sense? Or I can't do anything on that figure to manipulate it to tell R what I want to do next. I have to go back to R to change it. Shiny allows for that second bridge, right? The bridge from the user back to R, and R will come back with new results. Okay? So so to be clear, what's going on here? R renders this image. You change this. R noticed the change. It replots it with this new value in there, right? Where the bandwidth is 1.6 versus 1.4. Yeah. So, what kind of stuff can you give to R? Or what kind of stuff can you give in Shiny for like inputs? So these are what I'll call the defaults. Right? Pretty much all the basic stuff that exists in HTML, like buttons, checkboxes, drop-down menus, sliders. They've all been implemented in Shiny, and I'll show you the code to kind of generate that stuff. So checkboxes, action buttons, date inputs, date ranges, which comes up with a beautiful calendar. And I'm not being facetious on that because I've been on studies or, we've talked at length how dates are a nightmare, right? So things where it forces dates to be dates are very nice to me. File inputs, you can have people upload their data. One of the apps that I think I helped Jiawei with was people uploading their like accelerometry data, and then it would give them like summary measures and that kind of stuff, right? So similar with the Fitbit data, let's say you built something from Jeff's information that you like if I had my data, I would want to see this. You can have a web app, somebody uploads their data, and it runs, and then they can see the results of whatever you made.
So do you have to constrain what the format of their data is though, specifically? Because you'd be running the same code no matter what.
Yes. There's ways to make it more robust, but the more generalizable you want it to be, the more code you usually have to write, right? It can be let's say it was in rows instead of columns, right? That's just a simple thing, right? Then you would say if number of rows is greater than columns, transpose it, or if number of columns is greater than number of rows, then transpose the data or something like that. Or you have a checkbox saying that the data is in rows or columns or something. But generally, you kind of want people to give data in some sort of standardized way. Or you have app number 1, which standardizes the data, and app number 2 that actually renders it and does the stuff. Okay, so numbers, sliders, slider ranges, and text inputs. Okay. So the other thing I want to say is Shiny, we've all done a histogram. If you take bins and make them smaller, what actually happens. But basic, like teaching statistics, this is really, really important, I think. I think this is it would be the new way to kind of teach statistics to people. Because, all right, I'm telling you, let's plot a histogram and like overlay a density, and then like you show one plot, right? And it's done. It's next slide. But now you can say like, what if we dropped out like these 3 people or something, and then you click a button and they drop out, and then the thing gets re-rendered. So you can actually show how different operations or different things about assumptions about data, plots, models, that kind of stuff change with different aspects of it, right? You can change the link function to a log to a logit or whatever, and you can see how that changes. But I'm saying, theoretically, if this page is on a server that has R, and a student brings up the web page, then they'll be able to actually manipulate the things as well. So I tried a, let me see. I tried this, and it didn't work out. I tried it in the sense that I didn't send this to you yet, but the idea is ShinyApps.io isn't just a service anymore. So ShinyApps.io is RStudio, the company, their web service that allows you to push up Shiny apps. And now, Shiny presentations, or presentations that have Shiny aspects to it. So here. I'm going to send this, nope. I want you to open your computers and go to this. So this is going to be the same presentation I'm talking about, but the idea is you didn't have to install anything, you don't need R, right? And everything will actually work out. In the sense that you can run the presentation, and you can see the presentation. So you go through it, and now you can see, hopefully you can see, if you were like an instructor, and you were trying to demonstrate a concept, and everybody loaded this instead of a PowerPoint presentation, that they could actually explore the data as well, right? All right, now this was one of the examples. Sorry.
This is Shiny app embedded in Slideify.
No, this is not Slideify. So Slideify, okay, so that's a good question. So everything's written in R Markdown. So Slideify and Shiny are kind of merged at this point in some respects. I'll get to that in 1 second. So actually, let's go to the code. Then that'll be really illustrative. So this is what we got. Okay. For some reason, give me 1 second. These didn't come up. I was like, there's a plot. Oh, here we go.
I assume you sent us the code, right?
It's all in the GitHub.
Okay.
Blah, blah, blah. Oh, sorry. Okay. So here is the code that I used to make the inputs for this Shiny app. So the stuff over here, right? Sorry, it's a little out of order. All right, so there's number of bins, bandwidth adjustment. Okay? Those are 2 inputs. This plot is an output. So this is all the code that it tells you these are the inputs. Okay? So I want an input panel. I want a select input, right? So that's a drop-down menu. And I tell it what I want to call it. So this is like kind of a variable name in some respects. N_breaks. Okay? I want to say what is it labeled. So what is the user actually going to see? And I want to give it a list of choices. Remember, this is a drop-down menu. And so I want to give it the choices that the people can choose. And that I want to say which one is selected. So in this case, a default was 20 bins. If you don't give it default, it'll pick just the first one. Okay? Second, I want to give a bandwidth adjustment. This is a slider, not a select. Okay? Same thing. It goes whatever kind of input. The ID, which in this case, again, is like a variable name. I called it BW_adjust. The label, what does the user see on the actual web page? The minimum, the maximum, what a value is the default, and what kind of step. Okay? Does this make sense? That code turned into this.
So you said value is the default,
Value is the default.
but selected is the default when it's selected.
Yes.
Okay, so it doesn't use the same.
It's not always the same syntax for the default value. Okay. That gave you the inputs. This gives you the output. Okay? So, render plot, right? So almost all of the things that you're going to be doing as output are called render something. Render text, render table, render plot, render something. Okay? So here's where things get, when you start using Shiny, I think things get very confusing. These aren't functions. So, sorry. Render plot is a function, but its input is technically what's called an expression. The only thing you have to know about that is that you say render something, parenthesis, curly bracket, and you end it with a curly bracket in parentheses. That's really, at the end of the day, what the big difference is with these functions, right? And there is a little bit strange syntax, at least to me, kind of what's going on here. But the idea is you say plot, and then it's just saying, I want to evaluate all this code inside this. And whatever is plotted in here is what comes out on the screen. Okay, so I say I want to make a histogram. Faithful is a data set, already, one of the data sets in R, right? And I want to do a histogram of the eruptions, right? Everything up till here is just totally standard R, right? Nothing shiny. Here is where shiny comes in. So you remember when I said those things are like variable names? So once you run shiny, there's an object called input. It's all across two lines. Sorry about that, but it's input. So all the stuff that I made, so that slider, that text, if I had a drop-down menu, if I had a bunch of checkboxes, all that kind of stuff, all of that is contained in an object called input. And what you can do, you can think of that thing input as a list, more or less, like a list of parameters. So you reference that list with $, like you would any list that has names on it. So you say input $, what is the thing you want to grab? And in this case, right, back here, we called it n breaks. So we're saying we want to grab the number of breaks. And here, the as.numeric isn't necessary, but it's always kind of a good thing to do, just in case. That, like, if somehow a user enters something that isn't necessarily a numeric, in this case they can't, right, because it's just a drop-down menu, but just to kind of force it to be whatever you need it to be. And if it's false, if it's wrong, it'll make it an NA, and usually the code will error or something will go wrong. Okay, so right here, we made a histogram, and we have an interactive input for the number of breaks. Right? Not very crazy. So it's all R. That's the whole point. Everything written here is R. Now, also, we did, this shouldn't be surprising. We also did a density where we adjust by the bandwidth adjustment. And again, we say input $, the variable name that we called, or the ID that we used for the input. Sorry. So, I mean, sorry, let me go back. It's hard sometimes to get really excited about a histogram, right? But think about what it is. It is an interactive plot that I have embedded in a presentation, a slide deck, that's hosted on a web page. All of it was free. All of it was written in R. And it has total interactivity, right? It might not be the most exciting stuff. Oh, yeah, changing bandwidths, whatever. But, the fact that all that was done in R, if you, 7 years ago, if you told somebody you did that, it would So, I just want to just reiterate that this is a really cool thing. And so, who knows how who knows how to make this just to take a plot and put sliders. They don't even have to do anything in checkboxes. Who knows how to just make this web page in HTML? Right? Right, you have to declare a head, a body, and all that kind of stuff. Then you have to put like input and then say what kind of input it is. So like, let's just step back. You made an HTML web page and don't know any HTML. That's another big thing, right? And I'm not saying, again, it's just a histogram. But think about what all of it represents. Is that it's not just a histogram. It's an HTML web page that you didn't have to program in HTML. It has colors. It has default shading that's defaulted by a CSS script that they have, right? So you didn't have to know how to make the fonts different sizes or stuff like that, and that is stuff you can change. And it has interactivity, which requires JavaScript, which you didn't have to program. You guys seem super excited. Okay, I tried to do this example. This example failed in the sense that all I wanted to do was have a text box, right, where you had our code. And whenever you wrote in there, it would evaluate. And it works, except I couldn't make the text box bigger. So, for example, theoretically, right, so
that's the whole, what's the code in the box, the whole plot.
Yep. So, granted, again, I'm doing histograms. So it's like super like exciting. Everybody seems stoked. Right, but let me see. Let me look at Faithful. Let me see if I can do something more fun. Oh, I did not do ahead of it. Your eruptions and waiting. So I'm going to do... Look, I took all this stuff. So, like, right now, again, you're like, well, I already have an R console. Why do I need that? Right? Think about teaching. Think about teaching someone how to program in R. And on the left-hand side, you have code and the output. They didn't have to install R yet. They don't have to know what anything's doing. And then you say, like, change something over here, and it updates over here. Right? Granted, to you, who uses R on a daily basis, this is just standard bread and butter stuff. But teaching someone with stepping back and not talking about a console, not talking about objects or functions or anything, just having a plot on the right-hand side of a web page and the code on the left-hand side, I think is a really strong teaching tool. So Ramnav, the guy who created Slidify, I was going to say Spotify. He didn't create Spotify. Came a few years ago, and he showed something like this. He showed something like code on the left, like plot on the right, and you could change stuff, and it was all interactive, and it was all back-ended with this open CPU software. And I was like, that is crazy awesome. Like, that would be a great way to teach stuff. Except, like, he had created Slidify, right? He knows JavaScript. He knows how to do all this stuff. And it's like, that's awesome, but I didn't know that stuff. I didn't know how to do all that. So now, this stuff levels the playing field in some respects for you to be able to create things that you don't need to know extensive knowledge in some of these others, right? All this is a text box, but like, I can bring this to a collaborator and be like, fine, whatever you want to see, just put this variable here, and you'll see a plot of it, right? So it allows for you to theoretically create an entire interactive system that's built entirely on R, but the user doesn't see any of it. They just see checkboxes and clicks.
How did you import the list of Faithful?
So Faithful is just a standard default R data set that's already loaded.
Then what if we need specific data set from data portal or something?
Sorry, what?
What if we need specific libraries or data sets?
In like this example, I would do something like library ggplot2, and then you put it. So in R code, if you put semicolons, it acts as an entire break, right? So I could say like ggplot AES. So I can see, as you can see, why I probably wanted to try to do this to make this thing bigger, because otherwise the text box is really small. data equals faithful plus geom point.
So is the default just for that like text box to show up at the top of the?
So depending on how you can set like height and width and that kind of stuff. So in this type of default pattern, yes. Okay, so also I'm just going to talk really quickly. No, that's not even shiny. This is just our markdown, right? You can just say summary of a table. It's like that's great. And then when you say render table is a little bit different. Render table is a shiny thing, right? So if you don't have shiny kind of going, this doesn't really work so well. And you can say summary cars, and it's still really ugly. It's still very ugly. But it uses X table and plots it out in HTML. So it renders in HTML. Still super ugly, but at least I took away the stupid row names that didn't exist. Right? It just made 1 to 5. So just to be clear, render table is a shiny output, is a shiny function that will, whatever you put in here, it'll pretty much coerce it to a data frame, plot it out as an X table, right? So X table will take your normal standard data frame, turn it into something HTML, it will wrap all the stuff into HTML, and then it'll plot it, and then you can put options on this table here, and if you look at the syntax for print.xtable, I would bring that up, but it's like insane, like in the sense, like there's a lot of options for that. But I'm saying this is nice. This is how I would probably do standard results for like a presentation or something like that. But like I said, data tables might be a little bit better, right? Granted, you should never have to put more. You shouldn't put like more than like a 3x3 table in like any way. If it has data and like results, like a 3x3 or maybe 4x4, I'd say is the extent of any presentation size table you should ever do. So if I ever come to one of your talks and like JSM and you have like a 40x10 table, I mean, I might just walk out. Like, no, I'm just kidding, but not really. In the sense, you'll see that a lot, right? So this is just kind of presentation style. I would say you've seen it. All of you have at least seen it. Somebody does 3 different type of simulations in 4 different sample sizes with 3 different estimators, and it's like a 4x3x2 table or something. And that's all really nice and good if you want to check exact numbers, but that stuff's better in a plot anyway. So I'm just saying you could theoretically create an interactive table on one of your things, and that might be good for if you had a huge list of results and people really wanted to see the numbers or something, like beta coefficients and confidence intervals for all the things in their data set, and they could explore it. But in general, that wouldn't be something you do for presentation. Okay. Now, let's actually look at the code, because that's all the stuff that's really important here. The stuff that you guys will actually be doing. All right. So, everybody's got a computer today. Great. So, let's make one. So, RStudio, open it up. So, also, who doesn't have a GitHub yet? Everyone. So, I want to see everyone's presentation on GitHub by the end of this class. Or at least just pushed. Maybe not done or anything like that. Just the default one. All right, so RStudio, let's do new project. All right, new directory. Shiny web application. All right, then you put a directory name. What do you want to call it? All right, Steven, I'm looking at your GitHub after this class. I'm making sure it's up there.
No, I don't need to read that. I'm just going to clone G Suite and push to mine.
No, I will see that it's already it's clone. No. Okay, put a directory name. Put something in there. All right. Hit create project. Well, I don't know what to tell you. Download RStudio. Open this up. Start. So new project. Shiny web application. All good. Everybody got it? Good, great, grand. So you should have these two. So everything I've been showing you is kind of like phase 2 of Shiny. Phase 2 being that you can embed Shiny apps directly in R Markdown. And a lot of times you don't want all the other stuff with it. You don't necessarily want a presentation. You don't want like a document or something like that. You just want a straight web app, right? Oh, sorry, this didn't come with it. Did this come default, the UI and the server? Okay, good. Okay, before we get to UI and server, just try something for me. New file, R Markdown, shiny document, and click OK.
Wait. Oh,
Sorry,
sorry.
file,
Okay.
new file, R Markdown, click shiny, and give me a shiny document. Sorry, file, new, R Markdown, shiny, and then a shiny document. Okay? So we got this. And then I just want you to click run document. And then it'll ask you where to get it or where to save it. So now, if you save it and then save it and then click run document. All right. So now, all right, maybe your collaborator doesn't care about presentations; they don't need slides. This, right? If you can do it with R Markdown, you can do it with Shiny embedded R Markdown now. Granted, it has to be on an HTML web page. It has to have R running somewhere in the background. But this is a document where you can put like results, figures, anything, summary statistics, all that kind of stuff with this stuff we just talked about, right? Like this is a plot of our results for the regression. This is a summary of the data. This is a table. This is some other thing, right? This is the density of the data, all that kind of stuff. And then you can write paragraphs and paragraphs of the normal stuff you normally would to collaborators, right? I mean, maybe it's just dreary outside, but like this stuff is exciting to me. I don't know. This stuff is just really cutting edge, cool stuff. Because, in my opinion, a lot of the other systems are catching up very fast to R. Right? Python's at a breakneck speed, or it's coming, or it's already going to pass it very, very soon. SAS and Stata, they're staying in their own ways, but they're upgrading their graphics, I would say, a lot. But here, it's a very unique tool to be able to embed information in a document and have interactivity, right? Okay, that's all I'll talk about with Shiny in R Markdown. Now I'm just talking about straight bread and butter Shiny. Okay? Is that clear that there was like Markdown around it?
Is it not the same?
It is not the same because the endpoint of R Markdown in a document or R Markdown in a presentation is a presentation with embedded Shiny apps, I would call them. Shiny itself, it's just one app. That's the end goal. An app that does something. You can have multiple panels and that kind of stuff, but a web page that has inputs and outputs is the main goal of it. Okay. So, all Shiny documents or Shiny apps, right? Shiny apps have these two things. A UI stands for user interface, and a server. What code is going to get run, right? So let's go with the easier one. UI. The user interface is relatively straightforward. You put stuff in there that you want on the web page, right? That's it. So there's usually two things that you make, right? For a lot of the Shiny apps that you have. A sidebar and a main panel. It's a bar on the side, and that's the main panel, right? So sidebar, main panel. So pretty much you have a title panel as well, right? So if we look at this, it's just saying, what's the big gist of it? What's kind of like the plot name in some respects? It's not a plot. It's not just only for plotting. Remember, it's for like data output. It's for a lot of different things. But title panel will just give you the big name up here that's actually going to tell you what's going on. Sidebar layout, right? So it's just saying, this is the type of layout I want, right? Depending on your RStudio, I don't know. I think everybody should have the same things, or not, with your
Go
user.
back to the UI one.
Yeah.
I think I see something different. Unless I'm just confused.
I don't know.
This is header panel and not title panel. And
Yeah, so I just upgraded RStudio today, so it might be new. It might be new stuff because every time things were crashing.
I mean, it looks the same though. Like the actual output of it.
So I don't know.
I think it looks the same.
It might just be that certain things are redundant and certain things might become deprecated in the future. But for right now, they might have actually different functionality in that you could have overall title with multiple headers or something like that, like multiple header panels. But right now, header panel, title panel, just making a big thing at the top, just telling you what it is. And then I wanted to show you, where are the other layouts? So there's different types of layouts. The one we're talking about is a sidebar layout, something on the side, something in the main. Okay, in this case, the sidebar has just an input slider, and the main panel just has a plot. So we said, all we're saying for the sidebar panel, right, for this, sorry, I closed the app. For this thing, what do we want in there? And what we want is a slider input, right? So if you look at the help for slider input, it's got an input ID. Again, input ID, you can think of what do I call this in the list, right? In the list input, and I'll show you what I mean by that in a second. What do the user want to see in label, min, max, step, and it's got all these other things that you can add to it, but they're just kind of other optional targets. And then you close the sidebar panel. So sidebar panel is done. So this just ends the things that are going on the sidebar. Okay. The next thing that goes in there, and let's look at sidebar layout again. So if you look at it, the inputs for sidebar layout are a sidebar panel and a main panel. Okay. Just means like area or window for the panels. The idea is we put in the sidebar panel here. Great. Now we put in the main panel. So input functions have the word input in them. Sidebar input. Or sorry, not sidebar input. Slider input. Checkbox input. Group checkbox input. Right? So if I say checkbox input, right? You should know. So in this checkbox group input, there's a whole bunch of other things. Text input, select input, date range input, date input, numeric input. They're all inputs. Okay? Just driving that thing home. There is another thing called buttons, but we're not going to get to this today. But the idea is we have inputs. We have outputs. And so in the main panel, you generally put outputs. So what is this type of output? It is a plot output. So you have to specify that. So that if like this thing, whatever dish plot is, if something comes through there that's not a plot, it's going to say, I don't know what you're doing. This isn't, I assume the output of whatever's coming at me is a plot. Okay? So, just like inputs, outputs have IDs. Okay? So plot output dist. Dist stands for the dist plot, stands for the output ID. Okay? This will make a whole lot more sense in about 1 second. Steven, you coding that on your phone? Yeah, okay. Can't wait to see this GitHub repo, Steven. Yeah. Okay, so here's the server. Here's where the work happens. So, before, you see everything was wrapped around a shiny UI object. Shiny user interface. Server, everything's wrapped around a shiny server interface. Now, to obviously complicate things, the shiny server actually, its input is technically a function. I have no idea why. No clue. But the function takes inputs and outputs. Okay? So, all the things that I made on my server, or on my UI side, that say something something input, right? Slider input, for example. I can call input $that, right? And in this case, if you're using RStudio, it actually knows what those things are, what you call those things. So for example, let me make another one. So slider, or let's make a text input, blah, nothing. Okay, I made that. Now if I can put input blah, right? And let's say I want to make that the title of my plot. Right? So input $, this input list is how you grab the actual inputs. Does that make sense? If no, I'm going to talk about input for the next 20 minutes. No. Somebody, yes, right? That makes sense to most of you? It's a list type structure that has whatever you called over here, bins, blah, that is what is the elements of that list. Okay? Now, output is also an object. So you say output $, some ID, and by that I mean whatever you called the IDs of things in the user input, the UI.R, that's what you assign to output. So, okay, what is it saying? Output $display. Let's not worry about that right now. We have a render plot, right? And this is where all the code happens. You just wrap it all in some curly brackets. So we take the second column of faithful, call it X. We take bins, we bin it with the input bins plus 1, right? So whatever they put in for the input. And then we draw a histogram. Okay? Then we close the curly bracket and we wrap up render plot. So that whole thing saying, whenever I'm supposed to be called, render a plot. And what you have to do is then assign that to whatever you called the plot output, whatever ID you gave it to, and that is a list. That is an element of the output list. So, breaking it down just completely, hopefully, simply, there's inputs and outputs, there's a list of inputs, there's a list of outputs. Inputs you grab from R that the user set. Outputs are assigned in the server side, on the server.R. Outputs are assigned, and you assign them to whatever ID you gave that thing in the user set. This is a lot simpler than I'm making it sound. Like, it sounds really complicated. But whatever you call this over here, you say output $ equals that. And in this case, we did a plot output, so we did render plot. If I say text output, then I can say outputtout, right, is render text. Okay? So, this is the plot output, and I assigned it this plot. This is T out. I assigned that to T out, right? What is like glaringly unclear? Because there should be some stuff, because I'm not explaining this well, I don't think.
So the formatting between what you're doing just in this file and what you do in R Markdown is different, right?
Yes.
Like it seems different. I don't know if I haven't digested it yet, but
It is pretty much what R Markdown will do is it will take everything kind of out of the... Okay, so what the R Markdown actually takes in are things like this. Just the rendering stuff.
yeah.
You don't need to assign it to anything. You don't need to like do anything like that. Does that make sense? So R Markdown, the stuff, just takes the render plot, render text, render table, whatever those rendering functions is,
And like the
And on the back end, it'll assign it to something on the output. So you don't have to worry about that. And it just takes the inputs. So like the slider input, the text input. This is the only stuff you'd put in the R Markdown.
So, but if you're not using Markdown, you have to like wrap it
Yeah.
yourself.
So R Markdown will know what to do and pretty much wraps all this stuff together for you. Okay? I typed in something. It made a new plot with that label. Change the bandwidth. So, for example, one of the projects I'm working on with Michael, we're taking different type of trial designs, different sample size, like a really, I would say, fancy, sophisticated, but optimized sample size calculator. So let's say you wanted to do a clinical trial with like a bunch of people, and you had like some amount of sample size you thought, and you had some sort of hypotheses that you wanted to test, and you put all that stuff in there, and you click go, and R on the back end will tell you, is this trial feasible? What's the alpha spending function you should do, in a sense, like if you have 5 checkpoints that you're going to do interim analyses, what are the z-scores that you should have for cutoffs, all that kind of stuff. So all that stuff is written in Shiny to do a lot of stuff. Abandoned. So if your car in Baltimore City is parked in a spot for over 2 days, you can technically get a ticket because it's theoretically called abandoned. But Baltimore has an open 311 system, which allows you to see calls to the 311 system. Sorry, there's some vulgarity there. But the idea is somebody calls in 311 and says, this car's been here for weeks. I want you to ticket it. Okay? And that has happened in my car before because I left my car there for a couple days. And I didn't want tickets anymore. So I wrote a very simple function that tapped in the 311 system, found all the open cases, and tried to match them to some criteria that I had so that I wouldn't get tickets anymore. And I made a Shiny app because one of my friends had the same problem with it. So, for example, that's like a super basic thing you can do with with Shiny. That like these are all, so none of these are my car, by the way. I think I know that. I check it somewhat regularly, but the idea is you can just wrap stuff that you do in R and wrap some of the output that has or would be helpful with some interactivity, and you can wrap it all on Shiny, host it on shinyapps.io, so you don't have to worry about like starting an R server or servers or any of that nonsense, and then you have an entire working web page, kind of going on with that. Shiny. This is another example, and then we'll wrap up. I done a few years ago with Jeff, which was the CMS data, so the country medical service, what is it? I forget. But CMS puts out from Medicaid the cost of every procedure, right? Like the cost of procedures in a specific area. So let's say if we wanted to look at Maryland, and we wanted to look at which hospitals are the most costly, right, and we can actually see which ones those are. Northwest. So the average total payments, the total number of discharges in the data set there, right? So this is an interactive plot that is being resubset depending on what I'm clicking over here. So that was Hopkins. Okay? And the thing on the right is a Google map. And so that inherently already has some interactivity. So then you can embed it in a Shiny app, so you can have like, not only is the plot updating with these. So in Shiny, the only thing that are interactive are the inputs, right? But if you couple Shiny with like D3 or Google Maps or something that already has interactivity itself in the figure, then you can have interactivity on both ends. Okay.